Hello everyone, it's me Gagan Kumar present over here to teach you physics. Let's move on to the video. Today we will be discussing units and measurement, lecture number 02. In the first lecture we have completed what is unit and also some quantities like fundamental quantity, derived quantity, and in the fundamental quantity we saw length, and SI unit of length is basically meter. Now today we will be understanding how to measure length. Some measurement of length we will see basically, and some range of length also, and based on that some questions. Let us move on to the topic. So, here now in the measurement of length, so we have basically two methods, one is direct method, one is indirect method. So, here suppose I am telling this is your pen. So, how to measure the length of this pen? In last class also I told the same. Just take a scale, put it here, get the length of this pen. So, this is called direct method. That means there is certain instruments are there like a scale you can put and you can understand what is the result. So, that is called basically direct thing. So, in the direct method we have basically what? Now, meter scale. So, meter scale can measure. So, meter scale what basically? Now, meter scale one instrument, okay, you can measure up to what? Now, measure up to 10 to the power minus 3 meter to 10 to the power 2 meter. So, this is the range you can measure in a meter scale. So, below this you cannot measure, okay, less than 10 to the power minus 3 meter you cannot measure in the meter scale. So, for that one you need a different instrument. So, what is that? Now, that instruments are like Vernier Caliper, screw gauge or spirometer. Okay. So, this type of things you need. So, what is Vernier Caliper? Now, in the measurement section, okay, when you will study about error and all calculation, that time you understand what is Vernier Caliper, it is there in your exam. Okay, and definitely you can expect okay, one question, either list count of this Vernier Caliper or screw gauge or spirometer or some questions related to these two, Vernier Caliper and screw gauge. So, in NEET question we can get also. So, we will be discussing in the separate lecture we will discussing. Now, see, Vernier Caliper is what? Now, it is used to measure up to 10 to the power minus 4 meter, you see, which is basically less than 10 to the power minus 3 meter. So, it can measure up to that, and screw gauge can measure or spirometer can measure up to what? 10 to the power minus 5 meter. Okay. So, 10 to the power minus 5 meter the screw gauge or spirometer can measure, which is basically very less than 10 to the power minus 4 meter. Okay. Now, suppose I want to convert this 10 to the power minus 4 meter, 10 to the power minus 4 meter, how much centimeter? Remember, 1 meter is 10 to the power 2 centimeter. If we will convert this one, it will become 10 to the power minus 2 centimeter, which is 0.01 centimeter. So, 1 10 to the power minus 4 meter is nothing but 0.01 centimeter. So, this is the basically Vernier Caliper can measure up to this list measurement, this Vernier Caliper can do. Okay, or this 0.01 centimeter you can be written as what? 0.1 millimeter. Why 0.1 millimeter? Remember, 1 centimeter is nothing but 10 millimeter. 1 centimeter is 10 millimeter. If we multiply 10 here, it will become 0.1 millimeter. Now, similarly, 10 to the power minus 5 meter what? Now, that is here 10 to the power minus 5 into 10 to the power 2 centimeter, because 1 meter 10 to the power 2 centimeter. So, it is becoming 10 to the power minus 3 centimeter, which can be written as 0.001 centimeter. So, remember here point is there. That is equal to how much? 0.01 millimeter. Okay, because you can put here a 10 1, so it will become 0.01 millimeter. 0.01 millimeter. So, this is the idea you must remember. So, 10 to the power minus 5 meter, 10 to the power minus 5 meter or 0.001 centimeter or 0.01 millimeter, this much small measurement can be done by screw gauge. And these are direct things. Direct thing means how you are measuring length of this scale by putting that one. Similarly, take a small object, if you want to measure the diameter and all, simply this instrument you take and keep and measure. So, by hand you can measure these things and all. So, that is called basically direct method of measurement of the length. So, we understand what is direct method measurement for the length. Okay. Now, next thing we will go indirect method. That means where you cannot put your meter scale. You cannot put Vernier Caliper, you cannot put any other instrument to measure that length. Okay. Like suppose you want to find the distance from sun to earth. Now, what to do? You cannot take a scale, you can put sun to earth and you cannot get that length. So, there we have to do some other method. What type of method will come there? Now, that is called basically indirect method, that is called basically parallax method. What method? That is called basically parallax method. Okay. Now, what this parallax method? Now, this parallax method is used for large distances, okay, like between sun and earth, like that type of things. And in quantitative way, this large distance is what? Now, this distances should be less than 100 light years. Okay, we will understand what is light year actually, it is the unit of distance only. So, this large distance means not that too much large, it has certain limit also, how much? Now, less than 100 light years. Up to that one you can measure this in this method, parallax method. And remember this 100 light year also itself is too much big distance, because 1 light year I will explain, okay, that is basically distance travelled by light in 1 year. Okay, that is also big distance, that is order in the 10 to the power 15 meter or in the 10 to the power 16 meter it will come. Okay. So, that is basically light year distance. Now, large distances such as distance between what? Such a distance of star or a planet can be measured by the parallax method. So, this is the idea, remember here. And what is the thing basically parallax meaning? Now, parallax meaning means what basically? Now, the change in position. What is the change in position of an object? Change of position of an object with respect to a reference point when observed is called basically parallax. That means understand this way. Suppose here one object is there. Now, what I want to do? Now, I want to observe this object by my 2 eyes. Okay. Suppose I am keeping this eye closed and I am looking in this eye, then I will see some position of this object. Okay. This eye is closed. Now, when I will open this eye and I will close this eye, I will see this object position is on a different position. Similarly, if I keep doing that, you will see this pen will be moving like this way. You can observe this also. Keep your pen straight, then after hold it tightly, then after close one eye, see with another eye. Again close this eye, see with the other eye. Then after you will see the pen is shifting like this. So, that is the basically change of position of an object with respect to what? A reference point, that is called basically parallax. Okay. Now, remember the distance between 2 points of observation, that means whatever observation you are doing 2 eyes. So, these 2 points is basically what? Now, the distance is basically called basis. That means here you have 2 eye and here you are having object, this is the object, here it is your eyes, 2 eyes. Now, here you are measuring, you are seeing this object. Okay. So, here what is the distance between these 2 observations? This is called basically B, or that is called basis. Okay. Basis what? Now, the distance between 2 points of observation is called basically basis. So, this is called basically basis. This is just normal idea I am giving. We will be seeing in the next slide, we will be seeing how this thing works, how we can calculate, how we can tell the distance between sun and earth, the distance between moon and earth, okay, distance between 2 planets, distance between 2 stars, how we can tell. So, first thing remember here, parallax method is basically what? Now, to measure the large distances, and there is a limit in large distances also. What is that? Now, you can measure up to 100 light years. Okay. So, this is the idea about the parallax method. Now, understand how it works. Now, here I have 2 different cases, one is case 1, case 2. Now, understand here in the case 1, here this is your star, this is your what? In case 1, this is your star. So, here star is there and here this is the 2 point of observation. Now, what you are doing? This distance is called basically what? Basis B, and here one angle theta is there, you can write this B is called basis, and here theta is there, this theta is called what basis? This theta is called parallax angle, and this D is nothing but okay, distance of star. Okay. So, this is the distance basically like radius. Okay. Now, see here what it is happening like a plane angle system. So, you know already for plane angle system, suppose I want to write theta or D, whatever I want to write, suppose I want to write theta I can write as what? Now, this distance B divided by D. This implies D, if I want to write, then it will be B by theta. So, that also you can write. Okay. So, either you can write this or you can write this, And remember, when putting theta here, you need to put with what? You need to put with the radian, okay, because you need to find distance. So in terms of pi you need to put. Okay. So this is the idea to measure the distance from a star to some observation point here. That can be earth surface, it can be earth surface, and these are 2 points you can take that way. Okay. So this is one point it is coming. Now second thing is what and how it is coming. This is coming from plane angle formula. Already I told, if it is a radius r and this is the length L, then it is theta is basically L by r. Now here you come case 2. Case 2 is what? Now here your earth is there, and again here it is your star. This is your star. Now this distance is basically what? This is the d basically given, and here it is capital D. This is the radius, like, and this is alpha is called what? Alpha is called basically angular. Alpha is called basically angular size of star. Angular size of star, or you can tell it is your angular diameter. Angular diameter. Angular diameter. Now here also this d is called what? This d is called diameter of star. Diameter of star. Diameter of star. Okay. So this is the idea you must remember. Case 1, case 2 for your measurement of what? Measurement of length. So these two things you just remember. Based on this we will do questions. Whenever situation is like this, then what you have to use formula? Now formula use here alpha. Alpha equal to how much? Similar way, alpha you want to find this distance d by capital D. D by capital D. Okay. And you remember here this b is very much less than capital D. B is very much less than capital D. Okay, that's why this approximation you are taking, like what you are taking. Now here you are taking it like a length arc, some arc making, that arc is straight line coming. Then after triangle law you are taking like a tan theta is nearly equal to theta, that is nothing but p by b. In that concept actually you are telling, that's why this thing is coming. And remember here b, this b is basically basis, distance is very much less than capital D. Okay. So this is what you need to use in the questions. How to use this formula I will be explaining now. And here this capital D, if you want to tell, now capital D is nothing but distance between what? Distance between that star and earth. Okay. So capital D if you want to write, so you can write capital D is nothing but distance between star and earth. Okay. So this much things you must remember about this measurement of length. Now come to the question and try to understand. So here what telling question, the moon is observed from two diametrically opposite points A and B on earth. So here what they are telling? Now here they are telling, here earth is there. Now this is the A point, this is the B point. Now suppose this distance you take, this is the point of observations, so the distance is B. Now here you are having moon, here you are having moon. Now so for this moon what they are telling? Now here to here distance is basically D, here to here distance is D. Now here they are telling what? Now the angle theta subtended at the moon by the two directions of observation is 1 degree 54 minutes. That means here they given this is theta. This is your theta. So here what is this? Now this is your theta coming, which is given. Okay. So here you see these two observations or directions are making angle. This is theta. Now the diameter of earth is nothing but how much? It's 1.276 into 10 to the power 7 meter. That means it is your B. So this is the two opposite, diametrically opposite point. So this distance will be how much? B. Okay, that is nothing but 1.276. Now that means it is exactly matching with what? It is exactly matching with this case. So here moon is there. This is the two opposite point. These two are opposite point, diametrically opposite point of the earth. And this B is nothing but diameter of earth. Now here they are asking what? Now the distance of a moon from the earth surface is how much? Now distance is nothing but that is to find capital D. That means you need to find this distance. Okay, this radius or distance you can tell, you need to find that. And you see here some options are given. Now how to solve this? We will be solving previously what we have taken the formula. This formula most will use. So this is distance if you want to find, then it is B by theta. This formula we will use and we will solve this. And while doing this one I told, while putting the formula here, this theta should be in radian. not in degree or minute, not like that, it should be in radian you need to put. Okay. Now, we will be checking that. Now, here understand, here some options are given like this, some 10 to the power 6, 10 to the power 8, 10 to the power 7, 10 to the power 9 order. If you know the value or distance between between earth and moon, then easily you can tell what is the answer. No need to put this formula, no need to calculate anything. Okay. So, here the distance between moon and earth is basically what, in the order of 10 to the power 8 meter. So, here you will see 6, 7, 8, 9. So, it will be what, now 10 to the power 8 meter. That means you can put your answer C will be correct. Without any calculation you are telling answer if you know. But if any question changes happening, okay, some distance of other planet you are finding, different planet, you don't know, new planet. So, that time we must understand with this. So, we will try to calculate that one. So, how to do this one? Now, check here. Now, here what I am telling, now if solution I want to write for that question, my theta is given how much, 1 degree 54 minute. And remember, I no need this one, degree minute I do not know, I need to convert to radian. So, here what I will do? So, 1 degree is nothing but 60 minute and 54 minute is 54 minute, you total will see it is 114 minute. So, total how much theta is coming, 114 minute. And already you know 1 minute is nothing but how much, 2.91 into 10 to the power minus 4 radian. 1 minute is 10 to the 2.91 into 10 to the power minus 4 radian. Already last class we completed what is 1 second in radian, 1 minute in radian, 1 degree in radian. So, try to see the last lecture, you can understand. Now, here if theta I am writing how much theta, theta is nothing but 114 minute, but I need to convert to radian. So, 114 into, here what I can do, now in place of minute, 1 minute I can put 2.91 into 10 to the power minus 4 radian. Now, if you calculate this, you see it is little 100 plus and it is around 3. So, 3 into 100, it is basically 300, as another 14 is there, so it will go little more. So, you can write it is around how much, 332, or you can write it 3.32 into 10 to the power minus 2 radian. Okay. So, because this value will come as how much, 300 something, and here a minus 4, 10 to the power minus 4 is there. So, when it will become 10 to the minus 2 means you need because you are putting decimal point here. So, that is why it will become 10 to the minus 2. So, theta is nothing but this much. So, theta we got in radian. Now, we want to find distance. Distance is nothing but how much, that is b by theta. So, b is nothing but that is already given in the question, which is the diameter of the earth, or that is basically called basis. Okay, distance between two opposite diametrically opposite point. Okay. Now, here you go for this one. So, here what is happening, 1.276 into 10 to the power 7 meter, and theta is nothing but you are getting 3.32 into 10 to the power minus 2 radian. And remember, d is basically distance between moon and earth. So, definitely you have to write in meter. So, it will become around how much, 3.84 into 10 to the power 8 meter. Okay, you calculate this one, this will go up, it will become 10 to the power 9, and here 1.276 by 3.32, so it is 0 point something will come. So, if you will make 10 to the power 8, it will become 3.84 around. Okay. So, this is the idea you can put and you can get your answer. So, your answer is how much coming? The answer is coming here, which option C is the correct answer, and which is exactly we told, if you know the distance previously, then you can tell, if you do not know, then you can calculate from this method. Okay. So, I hope you understand. So, here just degree minute you have to convert to radian, and already other thing given in meter. So, now you can substitute and get the answer. Okay. Now, I will go to the next thing. So, this is the idea about how to find large distance without any direct measurement. Now, you understand, this is the idea how to find distance for a large distance without measuring directly. Okay. So, in indirect method you are measuring, you are using parallax method. Okay. Now, here let me go for another thing, that is called basically range of lengths. Okay. So, you will understand what type of length measurement we can do, some practical units of length. Okay. So, first of all, remember number 1 point, if you want to understand what is size of an atom, that comes around 10 to the power minus 10 meter. or in angstrom basically. So, it is basically angstrom unity. So, in the order of what? Now, 10 to the power minus 10 a meter. Now, suppose you want to understand what is size of a nucleus, size of a nucleus, that is around what? 10 to the power minus 15 meter to 10 to the minus 14 meter, like that approximation, or you can tell it is a Fermi. So, this type of measurement you must remember little. So, one Fermi basically this one. So, if you want to write here, so I can write 1 Fermi. 1 Fermi is nothing but 10 to the power minus 15 meter or femtometer you can tell, and 1 angstrom is 10 to the power minus 10 meter. Okay. So, 1 angstrom you can write in a symbol basically 1 angstrom, that is 10 to the minus 10 meter. Suppose you want to find 1 micrometer, okay, this is called micrometer, 10 to the power minus 6 meter. You want to find 1 nanometer, then 10 to the power minus 9 meter. You want to find kilometer, 10 to the power 3 meter. Okay. So, there are many units you can write, and if you want to write 1 centimeter, 10 to the power minus 2 meter. Okay. So, this is the conversation you can remember here, and 1 millimeter, already you know 1 millimeter is nothing but 10 to the power minus 3 meter. So, this type of things you remember, because most of the time you need to convert units and you need to calculate the things. Now, here number 4 I will tell, here you write 1 inch. 1 inch is how much? 2.54 centimeter, and 1 foot. Okay. In FPS system we see basically length unit is foot. 1 foot is nothing but how much? It is 12 inch. So, this type of idea also you can remember here. Okay. So, this is the basically small units you are understanding. So, this is the size of atom is angstrom order, and size of nucleus is in the femtometer order. Okay. So, one we will understand 1 astronomical unit, astronomical unit. Remember, this is also unit of basically distance basically. So, it is a range of length you are telling. So, it is a large unity measurement. Suppose you want to measure a large unit and all. So, this is astronomical unity. So, you can give yourselves a 1 AU. What is 1 AU? 1 AU means basically it is, that is your average distance between sun and earth. Between sun and earth is the average distance. Okay. Now, remember here what is 1 astronomical unit? 1 astronomical unit is nothing but 1.496 into 10 to the power 11 meter. So, this is a big unit, remember, 1.496 into 10 to the power 11 unit meter. Now, if you want to write 1 light year. So, what is 1 light year? Now, light year is nothing but, okay, light year is basically distance, it is also. So, it is a distance travelled by light in 1 year, distance travelled by light in 1 year. So, you see distance basically what? Now, speed into time. So, you know light speed is 3 into 10 to the power 8 meter, and 1 year you can convert into second, you can multiply, you will get 1 light year. So, that value if you will write, how much will come? Now, symbol of 1 light year is nothing but it will come basically, okay, 9.46 into 10 to the power 15 meter. Okay. And if you will little approximation you will do here. So, you can write it around 10. So, it will be 10 to the power 16 meter, like that you can tell, but it is remember 9.46 to 10 to the power 15 meter. Now, 7, understand, you will understand 1 parallax second. So, it can tell parallactic second. So, what is 1 parallactic second? Now, this is also called 1 per second. So, this is nothing but, okay, distance at which average radius of earth orbit, average distance at which average radius of earth's orbit, okay, makes an angle of 1 arc second, makes one angle of 1 arc second. So, this you can remember, distance at which average radius of Earth's orbit makes an angle of 1 arc a second. We understand what is astronomical unity, light year and parallax second, and 1 per second if you want to write. So, this is how much? Now, this will be 3.08 into 10 to the power 16 meter, and here you must remember these things, because sometimes question will be on this also, this 3 values. So, here if you will check perfectly astronomical unity and light year and parasecond. So, I can write one point. Okay. So, 1 per second is greater than 1 light year is greater than 1 astronomical unity. So, this type of relation is coming. So, star mark point you can remember here. So, this is the idea of a large distances. So, when a large distance you are talking the unity, that time you need to put these types of units. Okay. And these values also remember. So, it will help you to get this type of relations. So, parallax second is basically more larger distance as compared to because it is coming, you see, 10 to the power 16 meter, and here it is coming 10 to the power 15, it is coming 10 to the power 11, definitely 10 to the power 16 will be more. So, this is the idea. Okay. So, this much thing you must remember about the measurement of length and ranges of length. Okay. And this is the unity. So, different units of length. Okay. Now, I will go to the questions based on this. So, here telling which of the following. So, here telling which of the following represents unit of time. So, light year, sec, parasecond, astronomical unity. Now, remember here just now we studied. So, light year is not a unit of time, it is unit of distance. Okay, this is a distance travelled by light in 1 year. Parallax second also you understand, that is nothing but that is basically a distance at which average radius of earth makes an angle of 1 arc second, and astronomical unit is nothing but distance between sun and earth. So, these all are two distances, definitely this one will be unit of what? Time. And remember what is this sec? Now, sec is basically some informal unity. Okay. So, this is not SI unit and all, and remember in while studying that atomic physics and all, we use basically this unity sec. Okay. So, in higher advanced physics. So, sec is basically what? Now, 1 sec, remember 1 sec is 10 nanosecond, 10 nanosecond, or you can write 10 to the power minus 8 second. So, 1 sec equal to 10 to the power minus 8 second. So, this is a unit of time. Okay. So, although you do not know what about sec, so you know about light year, parsec, astronomical unity. So, definitely you can choose the which statement is unit of time. If 4 options are given, definitely one answer will be correct. So, you can choose this. Okay. So, I hope you understand all the idea regarding measurement of length. In the next video, we will be uploading more concepts on units and measurement. Keep watching the video, like and subscribe Vidhyalakshmi NEET Academy YouTube channel. Okay. Thank you very much. All the very best.